Okay, in today's video, we're going to be talking about hyperbolas. And again, a hyperbola is one of our conic sections. If you were to take a double cone and slice it with a vertical plane as this one slices it, you will get this double parabola looking shape as a cross section, and that's called a hyperbola. A hyperbola is a set of all points, and you see it over here. By definition, it's a set of all points such that the difference of the distances from any point on the hyperbola. Oops. Again. So if you were to take any point on the hyperbola and you measure the distance from one vertex or focus, excuse me, and the distance from the other focus, the difference between those distances will be a constant. So it'll be something like 7 or 7.5 or 8. But whatever the distance is, if this difference is 7, then you can pick any other point on this hyperbola and find this distance, subtract this distance, and you would get the exact same difference. So it's a constant difference. These fixed points are called the foci. You have a focus here and a focus here. As you did with a ellipse, you're going to notice a lot of similarities between a hyperbola and the ellipse that we talked about a few lessons ago. So therefore, in this situation, in this picture, D2 minus D1 remains constant. No matter what point you pick, it's going to be the exact same constant. Again, there are two different types of hyperbolas, just as you had with an ellipse. You have a horizontal hyperbola and you have a vertical hyperbola. Horizontal hyperbola is going to open left and right, and then the vertical will open up and down. You have the different parts. The center, first off, the center is and you got a focus here and a focus here. So let me label these. The center is going to be the midpoint of the two foci. So therefore, it's going to be the point right in the middle of focus 1 and focus 2. The same way over here, you have the focus up here, have another focus down here. The midpoint, the point right in the middle, will be the center of this hyperbola. Now notice here that the center of the hyperbola is not a point on the hyperbola. The asymptote lines are the diagonal lines that guide the curves. Okay, and let's talk about a little bit more about the asymptote lines in just a second, but I will point out here's the two asymptote lines. And as with any asymptote line, these lines guide the hyperbola. So the hyperbola, as it goes to infinity up or as it goes to infinity down, these pieces of this hyperbola approach. They get closer and closer and closer to these guidelines that we call the asymptote lines. Now, where do these asymptote lines, how do we find them? Let's talk about the vertices and the covertices. The vertices are the turning points, and I'm going to label them in a different color. Here you see a vertex, and here's another vertex, plural, that they're called vertices. Here's a vertex, and I'll put a V next to those. Those are the vertices of your hyperbolas. The vertices or the turning points are plus and minus a units away from the center, as it was identical to the ellipse. The covertices, the exact same thing, are the plus and minus b units away from the center. Now, something a little bit different here, the covertices are not on the actual hyperbola itself. So you see some covertices there. Now, there are two axis of symmetries that they don't list here in these notes that I do want to point out. You have what's called here that passes, I want to point out that it passes through the vertices, it passes through the focus. This is called the transverse axis. That sounds familiar. If you remember in geometry, we had a transversal. Was a line that passed through two or more other lines, as like when we talked about parallel lines cut by a transversal. So here you see the transverse axis. Oops. The transverse axis for the vertical hyperbolas. But again, the transverse axis is an axis of symmetry, and you can see it cuts it symmetrically that passes through the hyperbola. The other axis is called the conjugate axis. Now, in these cases, these axes are the x and y axis. That's not always going to be the case, but you have a transverse axis and you have a conjugate axis. Here you see the conjugate axis running this way. The covertices are always located on the conjugate axis. The foci and the vertices are always located on the transverse axis. The foci also, same as they were before, are plus and minus c units away from the center. And the formula for the C would be actually very similar to what we did before, but instead of with an ellipse, it was c squared equals a squared minus b squared. Here you have c squared equals a squared plus b squared, which is actually the Pythagorean theorem. And again, there's reasons for that. Now let's go back and talk about these asymptote lines. If you were to take, and I want to point out this box they have drawn, if you were to take and draw a vertical line through the vertices here, and draw horizontal lines through the covertices, it forms a box. And notice that the asymptote lines pass through the corners of those boxes. We're going to be asked shortly to find the equations of these asymptote lines, and that's the reason I want to point that out, is we're going to use the fact that it always passes through these corners. So that box is going to be very important to us. And here you see the box drawn there in the middle that goes through the vertices, that goes through the covertices to form that box. That again, the asymptote lines pass through the corners of. Okay, now the actual formulas. The standard form for an ellipse, or excuse me, for a hyperbola, a little bit different. And we're going to go ahead and go straight to the centered at HK form. You have the x minus h squared over a squared, and the y minus k squared over b squared, very similar to the ellipse. The only difference was when you had an ellipse, you had the equals 1, there was a plus sign there. With a hyperbola, the only difference is there's a minus sign. So therefore, this would be a horizontal hyperbola. And the way that you're going to be able to tell if it's horizontal versus vertical, because they're going to be very similar, is going to be this. With the vertical, the y stuff will be listed first, but look at this, a squared and b squared. This will be a little bit different for the hyperbola as well. A squared is always going to be the first squared term under the fraction or the ratio here. The b squared will always be the second term. That's going to be different from the ellipse because with an ellipse, the a squared was the biggest term, the b squared was the smallest term, but it's a little bit different with the hyperbola. Something else, the way that I remember the formula for the foci, keep in mind that again with an ellipse, this was a plus sign. However, the formula for the c was c squared equals a squared minus b squared. With a hyperbola, this is a minus sign, and c squared is equal to a squared plus b squared. So the way that I remember that is the formula for the foci is always opposite of what the actual standard form for your hyperbola or ellipse is. So there we go. Again, a squared is listed first, b squared second. The equation of the asymptotes, here's what I'm going to do. We're not actually going to give you the equation because there's a much better way. You can either use y equals mx plus b to find the equation, or we can use point slope, which is y minus y1 equals m parentheses x minus x1, which is the way I'm going to show you how to do it. And this is going to be the exact same form. That way we don't have to learn any more formulas. We can just use that. And that is just simply the method for finding the equation of a line. How to actually graph the hyperbola. Step number 1, we write the equation in standard form. Step number 2, graph the center. So we're going to find the center. Then we're going to find the vertices and the covertices. And again, we're going to use those to draw the box. We're going to draw the box in the middle. We can find the foci by, again, using that formula. And then we're going to write the equation for the asymptote lines. and actually graph it. So let's jump into some problems real quick. First problem says x squared over 4 minus y squared over 9 is equal to 1. So reminder that a squared is always the first number listed now, b squared is always the second number listed. Since the x is over your a squared, this will be a horizontal. I'm going to put that there. This will be a horizontal hyperbola, which means it's going to look like this. It's going to open to the left and right. It will have a transverse axis that is a horizontal line. And the conjugate axis will be a vertical line. So that means that A, let's go ahead and list this, that A will be positive and negative 2. And we find that from our A squared. B will be a positive and negative 3. The center, okay, if we look up here, to find the center, we simply look and see, is the x squared or y squared, are they translated? And they're not. So therefore, our center is going to be the origin. So the center is at 0, 0. And we'll go ahead and use our vertices and co-vertices next. Vertices are actually on the hyperbola. So this thing's going to go right to and left to. And this is because it's a horizontal. So your hyperbola is going to look something like here and here. It's going to be in those two areas. Next, we're going to go ahead and list our co-vertices. From our center, we're going to go up 3 and down 3. And there's going to be your co-vertices. And the next thing that I like to do is go ahead and use that to draw our box. And there's going to be the box that we're going to use to help us draw the actual hyperbola. Reminder that the asymptote lines are going to pass through the corners of those boxes. So if you'd like to, we could go ahead and actually find those asymptote lines. Again, the asymptote lines are going to be y equals mx plus b form lines. Reminder that m stands for slope, b stands for y-intercept. So you're simply going to find the equation of the line, and you can do it in the same color or a different color here, but you're going to find the equation of the line that passes through the center and the corner of the box. So we're looking for the equation of this line, and we're looking for the equation of this line that passes through the center and the corner of that box. And if you don't remember how to find the equation of the line, you need two things. You need a slope and a y-intercept. You can use actually another point on the line to find the y-intercept, but this one's going to be pretty easy because we can see the y-intercept. The y-intercept for both lines is actually the center right there. So really all we need here is going to be the slope. The slope we can use by finding these two values. Because if you look, we'll do this line first. Our rise is 3. Take any point on that line. We're going to rise 3. We're going to run 2, which are actually these B and A values. So our first line here is going to have a slope of 3 halves. So therefore, you have y equals 3 halves as a slope, so 3 halves x. Since the y-intercept is 0, you can put plus 0, but you don't have to. Your second line is going to be the exact same rise and run, except for it slants downhill. So your second line is going to be y equals negative 3 halves x. And there's your two asymptote lines. Next up, what we can do is we'll go ahead and graph it, and then we'll find our foci last, because the focus is actually not part of the graph. Since this is a horizontal hyperbola, the vertices are on the hyperbola, and all I'm going to do is I'm just going to sketch out a graph. I'm not going to draw a perfect graph. So there's half of your hyperbola on the right side. There's the other half, and just know that it kind of follows, it curves, starts with the vertex, and it curves to kind of follow your asymptote lines there. So there you go. That's your hyperbola. Just know that once you get it graphed, you can leave them, but these are not part of the graph. These are actually just things that helped us draw the graph. So the actual hyperbola itself is that. The foci, now you can go back and let's remind you on how to find the focus. There are two of them, and since we're dealing with a hyperbola, a squared plus b squared is equal to c squared. A squared plus b squared will be 13 is equal to c squared. So c is going to be plus and minus the square root of 13. So that would be c is going to be plus and minus 3.61. So therefore, and we've not listed our vertices, co-vertices, we've not listed anything here. So let me go back and list those for you. These were our vertices, our co-vertices. We went up 3 and down 3. And then our foci from the center is going to be 1, 2, 3.61, which are right and let's see, 1, 2, 3.61, somewhere there and there. So our actual vertices, we went from our center, we went right 2 and left 2, and then up none. Where co-vertices, from our center, we went up 3 and down 3. So there's our co-vertices. And our foci, this is what I like to remember. Our vertices and our foci are on the same axis. So they're going to look very similar. Left and right, 3.61, and then up 0. Problem number 2. There's no bottom under the x squared, so we put a 1. So therefore, our a squared value is always listed first as 36. Our b squared value is always listed second as 1. We can always check, too, if y is first on hyperbolas, this is going to be a vertical hyperbola. So it's going to be cupped up and down. So therefore, our a squared values will be up and down values here. So these will be on our transverse axis. So our a values are going to be plus and minus 6. Our b value, since b squared is 1, will be plus and minus 1. Our foci, if you want to go ahead and find it, a squared plus b squared is equal to c squared. So it'll be 37 is c squared. So c is going to be plus and minus the square root of 37, which is about 6.08. Okay, so our center, again, let's check. This has not been moved. We can check our x squared and y squared. There's no translations there, so our center is going to be at 0, 0. Let's go ahead and plot that, 0, 0. Since this is a vertical hyperbola, because y squared was first, our vertices and our foci are going to be on the transverse axis, which will be a vertical transverse. So we're going to go up 1, 2, 3, 4, 5, 6, and we're going to go down 1, 2, 3, 4, 5, 6. And our hyperbola is going to cup up and down from those 2 points. Now 6.08, you can plot those, but those are just going to be barely past those vertices, so you can see where those would be. So I'm not going to plot those, but they're located at, the vertices are at 0 and then plus and minus 6, and our foci are going to be at 0 and then plus or minus 6.08. Our co-vertices, and I'm curious, as close as those foci are to the vertices, I want you to see what actually that does to our hyperbola. Will it make it skinny or will it make it fat and chunky? Since the co-vertices are plus and minus 1, that means we're going to go right 1 and we're going to go left 1. And that's going to be located at plus and minus 1, 0, are our co-vertices. And we can draw our box from there. Through our co-vertices, we have vertical lines. Through our vertices, we draw 2 horizontal lines. And there's our box that we're going to use to actually draw our hyperbola. And now let's draw our 2 asymptote lines. And I went ahead and paused it so that I could get some better lines drawn there. So there's our 2 asymptote lines. Now let's see what we can do with the equations here. So the equations of our asymptote lines will be y equals, and we need a slope and a y-intercept, and the y-intercept is pretty easy. Both lines cross at 0. But the slope can again be found from our vertices and co-vertices, because this is a point on my lines, but now I just need to rise and run. And I know the line passes through the corner of this box, so I can rise 6 and run 1, which would be a positive 6 will be the slope of this line. And I can run 6 and run negative 1, so a negative 6 is going to be my slope here. So y equals 6x and y equals negative 6x. And since both lines have a y-intercept of 0, then that's going to be your b value for both. So therefore, there is our actual all of our stats or everything that goes along our properties of these hyperbolas. And since these are vertical, or this is a vertical hyperbola, from there we're just going to sketch the drawing. So the vertex is on the hyperbola, so this thing is going to go. It's going to follow again. It's going to follow these asymptote lines up through here. So there's the top part of my hyperbola. And then the bottom part of my hyperbola is going to be somewhere right around in there. And then the other side, and again, I made it touch there, but it actually just follows right along. So that blue part is your actual hyperbola. Next problem. And your a squared is listed first, so a squared is 25, b squared is 16. And then c squared, we can go ahead and, whoops, I got ahead of myself. C squared we find by doing a squared plus b squared, so c squared is 41, which means that a is plus and minus 5, b is plus and minus 4, and c is plus and minus 6.40. The center of this hyperbola has been moved this time. A -3 and a -2 always works opposite, so that's going to move it right 3 and up 2. So that's going to be a +3 and a +2 will be our center. So our center is located at 3, 2, which is right there. And then that's going to be the center of all of our work. Let's see if it's horizontal or vertical. Since the X stuff is listed first, this will be a horizontal, which means the transverse axis will be horizontal. The conjugate axis will be vertical. So let's see if we can find those vertices. Okay, we're going to go, again, since the transverse axis, that's where my vertex is located. I'm going to go left and right from this dot. So I'm going to go left 5, and I'm going to go right 1, 2, 3, 4, 5. And that's going to be my dots for my vertex. Since I went left 5 and right 5, let's actually get the vertices here. Right 5 would be 8, 2. Left 5 would be -2, 2. The co-vertices are found by going up 4 and 1, 2, 3, down 4. That's going to be located at 3, -2 if you go down 4, and 3, +6 if you go up 4. So there's all those. Let's draw our box that we're going to use to find our asymptote line. So there's passing through, let's see, that would be my vertices since it's a horizontal. And then pass through your co-vertices here. And I'll pause and draw my lines for the corners. And there those are. My foci, let's see, my foci are going to be located on my transverse axis. And again, since X is listed first, it's going to look like this. So that means my foci will be on this transverse axis to the left and right. So from the center, I'm going to go right and left 6.40. So that's going to be 1, 2, 3, 4, 5, 6, and nearly 6.5. So there's going to be 1. And the other one's going to be the same distance outside my box on the other side. So if you go right and left 6.40, that means your foci are going to be at right 6.40 would be 9.40, comma 2, and left 6.40 would be -3.40, comma 2. Now let's draw our hyperbola, and I'll do it in green here. So again, we just go to our vertices. There's the first one. And we just follow our asymptote lines and do the exact same thing there and just simply follow those asymptote lines. So if you actually wanted to see, again, all that middle is just extra. This is not part of your graph, so you could actually erase, and your actual hyperbola is that. It's the 2 green lines. So without all the other ones, it looks like a pretty clean graph there. I know it's not great, but it does look better. Now, our asymptote lines, let me put all the material back up there so that we can actually find the asymptote lines here. And this one will be a little bit more difficult to find these asymptote lines. Now, the slopes, that part will be easy. Y equals and y equals. The slopes are simply the rise and the run, which would be 4 and 5, which you can find by these two values here, because to get from the center up to here would be 4, and then over to here would be 5. So y equals 4/5 and y equals negative 4/5 x. That's going to be the slopes are 4/5 and negative 4/5, and you can check me on the negative 4/5. However, the y-intercepts, it's going to be a little bit tougher. That one looks like it's at 0, but I'm not certain. But how to find those are going to be a little bit more difficult. And one method of doing that is by using the slope-intercept or the point-slope form, whichever way you've done it in the past. We'll use point-slope here, and the way that you do that. Point-slope is a formula that you can use, that you can plug in a slope and you can plug in a point that's on a line to give you the equation. So what we're going to do is we know that this center right here is actually on both of these lines, so we can use the center as a point on either line. So I know my first line, let's do it. My first line has a slope 4/5 and it passes through the point 2, 3. So here is the information. We clean that up by distributive property first. So 4/5 times x is 4/5 minus 4/5 times 3 would be 12/5. And I forgot my x there. Move the minus 2 over by doing plus 2, and you get your first equation as y equals 4/5 x. And then let's say negative 12/5 plus 10/5 will be negative 2/5. So it looked like it crossed at 0, but it didn't. It actually crosses about negative 2/5, a little bit lower than what you see there. Our next equation, you can actually just erase this, and or you can rewrite the whole thing. Your next equation also passes through 2, 3, but it has a slope of negative 4/5. So that's going to be y minus 2 equals negative 4/5 times x, and then negative 4/5 times negative 3 would be a positive 12/5. We're going to move minus 2 by adding 2, and that's going to be plus 22/5 whenever you add 2 to it, which would be about 4 2/5. So your second line has a slope of negative 4/5 and passes at 1, 2, 3, 4 2/5. So that looks about right. Next problem. A squared is the first value listed is 36. B squared is equal to 9. C squared is a squared plus b squared, which would be 45. So therefore, your A value will be plus and minus 6. Your B value will be plus and minus 3. Your C value will be plus and minus 6.71. Since Y is listed first, this will be a vertical hyperbola. So therefore, your vertices you're going to find by going up and minus 6 from your center, but we've got to focus on our center. Up 3, or excuse me, yeah, actually, since the 3 is on the y value here, you got to be careful. That's going to send your hyperbola up 3, and this plus 1 on the x is going to be left 1. So we're going to go left 1, up 3, left 1, up 3. So you got to be careful about which numbers actually with the x, which numbers with the y, and the direction it's going to go. So negative 1, 3 is our center. Since it is a vertical hyperbola, from there we're going to go up 1, 2, 3, 4, 5, 6, and we're going to go down 1, 2, 3, 4, 5, 6, and that will carry us to the vertices, which are now going to be at negative 1, 9, and negative 1, negative 3. There's your two vertices. Your co-vertices are going to be found by going right and left 3 from your center. So we're going to go left 3, and we're going to go right 3. So that's going to be negative 4, 3, and 2, 3. So there's your box found by doing your vertices and your co-vertices. Now let's draw the box through our co-vertices, and then draw the 2 lines through our vertices here. If you want to do your focus next, it really doesn't matter. Your focus, since these are going to be vertical, your foci are always located on, again, the transverse axis. So that's going to be your up-down axis in this case. So from our center, we're going to go up 6.71, and that's going to be at 5.71, comma 3. And then we're going to go, and I believe I went the wrong direction, up 3.7 or 6.71, so that'll be at 9.71. And then down 3.71, which would be at negative 3.71. So that's going to be at negative 1, 9.71, which is going to be located, let's see, for this other one, we went up 6, so it's going to be about right here and about right here would be our two foci, which again does not really impact our graph. You can put them on there if you'd like. Let's draw our lines from the center, passes through the corners. So that's our first asymptote line from the center passing through this corner. There's our second asymptote line. So our two asymptote lines, we can go ahead and find them if you'd like, will be y equals. We need a slope. And the slope of this line is, since from the center we went up 6 to get to our vertex, we went right 3 to get to our co-vertex. So therefore our rise will be 6, our run is 3. 6 over 3, that will be 2 is our slope. Our other line should have a slope of negative 2. And yes, they will always be opposites of each other. Now we need to find our y-intercepts for each of those lines. So the way we can do that is we can use the center and we can use each slope and we can plug it into a point slope formula. So I'm going to do it right here just to give me some room. You have y minus y1 equals m times x minus x1, and since x1 is negative 1, you have this. That'd be y minus 3 equals 2x plus 2. To get rid of minus 3, we're going to do plus 3, so that'd be y equals 2x plus 5, and we can check that. So this should cross at 1, 2, 3, 4, 5, and it does. Looks good. Our second asymptote line also passes through the point negative 1, 3, but has a slope of negative 2. So you have y minus 3 equals distributive negative 2x minus 2. To get rid of minus 3, we're going to do plus 3. And that gives me my second asymptote line is y equals negative 2x plus 1. And that looks good as well. So there's your two asymptote equations. And then the actual hyperbola itself is going to look something like this. There's the top part. And there is the bottom part. Next problem. Number 5. Okay, on this one, a little bit different. You don't have equals 1, so the first step, we do have to get this in standard form. So anytime you have equals a number, we're going to just go through and divide by that number every term. 4 over 100, we can reduce that to 1 and 25. 25 over 100, we can reduce that to 1 and 4. Then 100 over 100 is 1. So there is your actual hyperbola. In standard form, it will be a vertical because of the y stuff being listed first. Your a squared value is 25. Your b squared value is 4. Your c squared value, since a squared plus b squared is c squared, is 29, which means you have a vertex at plus and minus 5 from the center, a co-vertex at plus and minus 2, and then a foci at plus and minus 5.39. So let's go through and graph all those. The center, notice there's no plus and minuses on the y's and x's, so we have a center at 0, 0. So let me plot that. Let me go ahead and draw the vertices. Since it's vertical, we're going to go up 1, 2, 3, 4, 5. We're going to go down 1, 2, 3, 4, 5. We're going to plot our co-vertices, right 2 and left 2. So our actual vertices are at 0, plus and minus 5. Our co-vertices are at plus and minus 2, 0. Our foci are going to be, again, since it's vertical, it's going to be up and down. So 0 plus and minus 5.39. And I'm not going to plot those. You know that you can. The asymptote lines we'll find in just a second. Let's go ahead and draw our box. And there you see your box. Let's draw our asymptote lines through the corners and through the center. And there are your asymptote lines. We can go ahead and find the equation of those, and these should be easy because they pass through the center. So we know that our y-intercept for both lines will be 0. Our slope will be the rise and the run here, which will be the 5 and 2. So y equals 5 halves x, and y equals negative 5 halves x. And again, the y-intercept for both will be 0. And then we simply sketch out the actual hyperbola itself. And since it's going to be a vertical, we're going to sketch it here and here. And there's your hyperbola. Okay, the next one. Number 6. Now this one we're going to have to complete the square on. We've got 10x stuff. So what we're going to do, just a reminder, we group. So x squared plus 10x is grouped together. You can leave a space for completing the square. Put all your y squared stuff together. We don't have to worry, or all your y stuff, we don't have to worry about completing the square there because there's no y term. There's a y squared but no y. And then the constant you leave on the other side. We complete the square by taking half and squaring it. That's going to be a 25. Make sure we add it to both sides. We always factor after completing the square. This will factor into x plus 5 times itself. Bring down minus 9y squared, and then negative 16 and 25 is 9. Again, since we don't have a 1 over here, we're going to divide everything by 9 to give us a 1. And that makes our equation x plus 5 squared over 9 minus y squared over, and I'm going to go ahead and put that 1 on bottom just so we don't get confused, is equal to 1. Now there is your standard form. So the center has been moved left 5, but has not been moved up or down any, so therefore we can go ahead and put our left 5, 0 for our center, and that's going to be at 1, 2, 3, 4, negative 5, 0 right there. Our a squared value here is 9. Our b squared value is 1. Our c squared value will be 10. So therefore a is plus and minus 3, b is plus and minus 1, and c is plus and minus 3.16. This will be, since the x stuff is listed first, this is a horizontal hyperbola. So our vertices are going to be left 3 and right 3. So that's going to be negative 2, 0 is right 3 and negative 8, 0. Our co-vertices are up and down 1, which will be at negative 5, 1 and negative 5, negative 1. Our foci will be up and down, or excuse me, left and right, since this is horizontal. So that's going to be negative 8.160 and negative 1.840. We'll go ahead and plot our vertices and co-vertices from the corner or from the center. So we're going to go right 3, left 3, up 1, down 1, and draw our box. Next, we connect the corners of our box to draw our asymptote lines. And there's the asymptote lines. Something else that's going to be a little bit more difficult here is finding these y-intercepts, because in order to find the asymptote lines here, they're going to be y equals. The slope is going to be rise 1, run 3. So 1/3 x and negative 1/3 x will be the other equation. But our y-intercept, again, is going to be a little bit tougher. So we're going to use point slope. So you have y minus y1, that won't be near as bad, equals m times x minus x1 is negative 5, because again, the center of your hyperbola is on your asymptote line. The minus 1 won't matter, so I can just actually distribute that 1/3, so you get 1/3 x plus 5/3 will be your first equation. And then your second equation, that positive turns to a negative, so it'll be negative 1/3 x minus 5/3. So it wasn't as bad as I thought it was going to be. Then the last step, we actually just draw our hyperbola. Remember, it's a horizontal, so therefore, there is what your hyperbola will look like. Number 7. Again, on this, we're going to have to complete the square. The x squared, that's the only x stuff that we have. The y squared, we're just going to group it together. Leave a space for completing the square equals negative 45. In order to complete this square, we're going to half negative 6 and square it. That's going to add 9 to both sides. We now have negative 36x squared plus, let's go ahead and factor that. That's going to be y minus 3 squared equals negative 36. Now, something weird happens with this one when we go through and divide everything by negative 36, because we're not used to having a negative 36 there. It turns this into a positive x squared. This minus right here can actually be written up here. So that's going to be minus y minus 3 squared over 36 equals 1. And since there's no bottom there, let's put it as a 1 to make it look like a hyperbola. So there is your basic form of your hyperbola. A squared is 1. B squared is 36. C squared is 37. So therefore, A is going to be plus or minus 1. B plus or minus 6. C is plus or minus 6.08. Your center of your hyperbola is 0, positive 3. So 0, positive 3. This is going to be the center. So let's write that here, 0, 3. Your vertices, since the x is listed first, this is going to be a horizontal hyperbola. So your vertices are going to move right 1, left 1. Co-vertices up 1, 2, 3, 4, 5, 6, and down 1, 2, 3, 4, 5, 6. So those are located at we can actually just do plus and minus 1, 3 for our vertices, and then we'll have to write the co-vertices out. That'd be at 0, 9, and 0, negative 3. Your foci are going to be right and left of your right and left of your center. So that's going to be, we can write that as plus and minus 6.08, comma 3 are going to be the two foci. Now let's draw the box and then the asymptote lines. And there we go. Let's go ahead and find the equation of the asymptote line. So y equals and y equals. We need a slope, so we're going to rise and run from the center. We rose 6 and we ran 1. So that'd be a slope of a 6 and a negative 6. And luckily on this one, the y-intercept is going to be so easy because the y-intercept is the center. So plus 3 and plus 3 is going to be the y-intercept on both of those. And then finally, let's go ahead and draw the hyperbola. This is a horizontal one, so that's going to make this a pretty large, fat hyperbola. So you see there in green what the hyperbola would actually look like. And again, if you wanted to erase all this middle junk, you could get a better picture of what that hyperbola actually looks like. And it's so wide that it's nearly a straight line there. Okay, last problem. This one we're going to have to do a lot of major work on completing the square here. So we have negative 4x squared. Group all your x stuff together. Group all your y stuff together. And then the constant stays on the other side. If there's a number in front of x squared, it has to be factored out. So we got negative 4 parentheses x squared minus 10x. Leave some space to complete that square. If there's a number in front of y squared, it has to be factored out, but there's not one here. Just leave yourself some space. Now let's go through and complete that square. Half of negative 10 is negative 5. Square it gives you 25. Be careful what you add to both sides because you did not add a 25 to this side. You added negative 4 times 25, which is a negative 100. Inside the second parentheses, half of 12 is 6. Square it gives you a positive 36, so add that also to both sides. So anytime we complete the square, our next step is to always factor. This will factor into x minus 5 squared, plus the y stuff will factor into y plus 6 squared, equals, this is 16 on the other side. All three terms, you're now going to have to divide by 16 to make it a 1 on the right side. Negative 4 over 16 is a negative 1 over 4, and you leave the x minus 5 squared on top. The second one is good to go, and then equals 1. Now there's a problem. Because hyperbolas, the minus sign is supposed to be in the middle. That's fine. Just switch these two terms. And write this as y plus 6 squared over 16 minus, which goes with the x minus 5 squared stuff, over 4 is equal to 1. So therefore you have an a squared, a b squared of 16 and 4. So that means you have an a of plus and minus 4, a b of plus and minus 2. Since c squared will equal a squared plus b squared, that means that c squared is 20. So that makes c the square root of 20, which is about 4.47. 4.47. So there's your a, b, and c values. The center, okay, your x value is over here. So this would be right 5, down 6. Right 5, down 6 is your center. This is, since y is listed first, this will be a vertical hyperbola. So we're going to go up and down to find our vertices. So that's going to be 5, negative 2, and 5, negative 10. You can go ahead and find your foci if you'd like. Go up and down 4.47. It's going to be 5. That'd be negative 1.53 and 5, negative 10.47. If you go up and down there from the center. Find the covertices. Again, we go right and left. That'd be at 7, negative 6, and 3, negative 6. Let's plot all of those and draw our box. And there's your box with your center there in the middle. Then you connect the corners to draw your asymptote lines. There are your two asymptote lines. We can go ahead and find the equation if you'd like. That's going to be y equals. The slope is going to be 4 over 2, which again can be found here. So that's going to be y equals 2x and negative 2x will be your two slopes. Your y-intercept can be found because, again, each of these lines pass through the center. So let's do y minus y1, which would be negative 6, equals m, which is 2, x minus x1 will be 5. Distributive property would be y plus 6 equals 2x minus 10. Subtract 6 from both sides and you get 2x minus 16 is this line, or this asymptote line, and it would cross down here at negative 16. The second line, the only thing we had to change, it also passes through the center but has a slope of negative 2. So you have y plus 6 equals negative 2x plus 10. Move my plus 6 by minusing 6, and that'd be negative 2x plus 4. So this line, if continued on, should cross up here at positive 4. So there's your two asymptote lines. To finish your graph, this is a vertical hyperbola. So you simply sketch the graph above and below, and it would look something like that.